Now we're live. Okay, so today's topic, we're talking about transformations of functions. Okay, so when you see the word functions, don't freak out, just say, Mr. Davies is talking about graphs, okay? But they got to be graphs that work, right? They got to be graphs that wouldn't be like crazy Mr. Davies latte stand, right? They've got to be graphs that would pass the vertical line test. So functions, we're going to think about graphs, okay? But it's, the proper graphs that are functions, okay? So here's example one. So I have this graph, but I don't really have the equations of it at all, okay? But so here's the graph. So I'm going to do a visual. So if I just look at this graph, and what I'm going to do is draw f of x plus 2 and y minus 1. Okay? So what does this mean? That all x values increase by 2 and all y values decrease by 1. Okay? That's what it means. F of x plus 2. So all my x values are going to be increased by 2, and all my y values are going to decrease by 1. And that's the hard way to do it, but that's really what it means. For us, the easiest way is to just take this graph, the entire graph, and we're just going to move it over to the right 2. Boom, boom. Okay, because if it's plus 2, take the whole thing over 2. We'll take every single point and move it down 1. That's all we're going to do, because that would make everything increase by 2, all the x values, and then it'd make all the y values decrease by 2. So what I'm going to do is take... So when I say all the important points, I'll take like all these little corner points. I'll take this point at 1, 2, 3, 4, negative 4, 2, and I'll move it over 2, 1, 2, and down 1. That's all I'm going to do. I'll take this corner point here at negative 2, negative 2. I'm going to move it over 2, 1, 2, and down 1. Okay, so I'm just taking the important points, like the corner points, because I'll move the lines once I connect the dots, right? I'll take the point at 0, 0 and move it over 1, 2, and down 1. Okay, so I just move the origin over 1, 2, down 1. I'll take this corner point right here is where they're connected, and I'll go over 1, 2, and down 1. And I'll take this very end point, I'll go over 1, 2, and down 1, okay? And then if I connect the dots, I basically have moved the entire graph to the right, or increased every x value by 2 and down 1. Okay. Pretty easy, right? Pretty easy. And that's what this says. Take every x value, move it over 2, take every y value down 1, so I just took every point over 2, down 1. I moved them all by doing that, didn't I? Okay. That's why I drew the lines, but every single point moved over 2 and down 1, right? Thumbs up? Okay, I know it's early. Got one thumb up maybe? Okay, there's 2 thumbs up. All right, example 2. So in example 2, we're going to reflect g of x over the x-axis. So this is the x-axis, okay? So if it's going to go over the x-axis, some kids can visually see this. They can take it and just rotate like a barbecue, or like, you get a little barbecue skewer and just rotate it around. And if you can't see it, then I'll show you an easy way to do it, okay? So let's take this corner point. It has a height of 3. If I flip it over the x-axis, it's going to go down to negative. Does that make sense? I've got a height of 3. Flip it over to negative 3, okay? This important point, or this corner point, is down 1. So if I flip it over the x-axis, it's going to go up 1, right? This same corner point here at the end is down 1, so I'll flip it up and I'll go up 1, right? Here at the y-axis, I'm down 2, so I'll go up 2. Here at x equals negative 1, I've got a y value of negative 3, so I'll pop it up and make it negative 3. Here, this is about up at 1, so I'll bring it down to negative 1, and I should be able to draw my graph in, okay? So anytime we do a reflection over the x-axis, we go from g of x, and we make it equal to negative g of x. Or every y value changes sign. If you're going to go over the x-axis, right, everything that's up comes down. So if it's up at 3, then it goes down, negative 3, right? If it's down at 4, it go up to 4. So it's all the y values that change to make it go from like this up to that. Okay? Thumbs up? Seem pretty easy? All right, you guys are tired, aren't you? It's only Tuesday. What are we going to do when Friday rolls around? Because we zombies, huh? All right, slide it up. Okay? This time we're going to reflect over the y-axis, okay? So when we do a y-axis, we're going to take p of x. We're going to make it equal to p of negative x, okay? Or every x value changes sign. So to go over the y value, okay, go over the y value, if I go over 3, I got to go back 3. Those are x values, right? If I go back 5, those are x values. I go forward 5. So just change all my x values so the whole thing goes to here, right? Now the heights don't change, right? So the y values never change, but the x values change to the old slide on over, okay? So let's see if I can do that, okay? All right, let's start way here at the very end. So this is back at 1, 2, 3. So let's just flip it over and bring it over 1, 2, 3, okay? This little corner point here is back at negative 1, so we'll flip it over and bring it to positive 1, right? Now I love this point at 0, 0. It's not going to change at all. 0, 0, it's not going to change. Let's see where it's at. This x value is over 1, so now it becomes back to negative 1. This corner point, which is at 2, comes back to negative 2. And this at 1, 2, 3, 4 goes over at 4, but then it's come back at 1, 2, 3, 4. 1, 2, 3, 4. There we go. And I just go ahead and draw it in. It should, if I do a good enough job, it should look right. Okay? Can you see it? Does it look like it got flipped over the y-axis? And every x value changed sign. If the x values were positive, it became negative. If it was negative, it became positive for the x values, okay? Thumbs up. Okay, ready to turn the page? All right, here we go. Here's our parabola, right? Here's our parabola. So we're going to translate parabolas. So let's first start off with the basic parabola, okay? We know how to do this, right? In fact, we just did this, and we're going to do the t-table in our head. That's the best way to do it. Okay, what we do know is we're going to take that shape, which is on the whiteboard, and we're going to put it right there, okay? So real quickly, we're going to plug in, we will plug in 0, 1, 2, 3, and we'll plug in negative 1, negative 2, and negative 3. But we're not really going to plug those in because we're going to do it in our head. We're going to use our brains because we know what 0 squared is, we know what 1 squared is, we know what 2 squared is, we know what 3 squared is, right? We know what negative 1 squared is, we know what negative 2 squared is, we know what negative 3 squared is. So let's just put it on the graph, okay? So right off the bat, you ready? All right, Emily, what's 0 squared? Yep, so we got to point at 0, 0 because I plugged in 0 and got 0, okay? Keisha, what's 1 squared? So if I plug in 1, I get 1, right? That's how easy it is. Emma P, if I plug in 2, what's 2 squared? 4. 1, 2, 3, 4. Let's see. Leora, hard question. 3 squared. What's 3 squared? 9. So I plug in 3, I get 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, okay, we're smart. We're smart. Do I really need to plug in negative 1, negative 2, negative 3? Do I really need to plug those in? Do I need it? What's negative 1 squared? Who cares? What do I know about my graph? Fancy math word. What do I know about my graph? It's a reflection, isn't it? Right? So it has symmetry. You know that word symmetry? It has symmetry. So because it has symmetry over the y-axis, I already know I have a point here, right? I have a point there, a point there. Okay, so let's just graph that. Just put it in. There we go. Okay, there's our parabola. That's what we call our parent function. That's my parabola. That's my parent function. We call it a parent function because it is the basic. It is the godfather of parabolas. And then it starts to have crazy children from there that start to change, okay? But that is the parabola, right? That's why we call it the parent function. Now, let's change it. So, if I'm going to graph 2f of x, what do you think the 2 means? Yeah, Caleb.
You multiply it by 2.
If we do multiply by 2, so what happens is you plug in the x's. So the x's don't change because you plug in the x's, but it's the heights that change. So it's going to be twice as tall. But the x values don't change because you plug in 1, plug in 2, you plug in 3, right? But what changes is their heights. So instead of going 1, 1, we're going to go 1, 2. So they're going 2, 4, we're going to go 2, 8. So they're going 3, 9, we'll go 3, 18. And of course it's symmetrical. So let's do that, okay? Let's see how that works. All right. We do know 0, 0 for sure because 0 squared is 0 and twice as tall as 0 is 0 times 2. It's got to be 2, huh? But now 1, we know you normally go 1, 1, but the height of 1, we're going to double that, so we go up to 2. So it's twice as tall, okay? Twice as tall, right? So I'm going to go 2, and normally I'd go 2, 4, 1, 2, 3, 4, but I'm going to go twice as tall, so we'll go to 8, 4, 5, 6, 7, 8. 3, 18 is probably going to be off the paper, so I'll just squish it way up there, okay? But it's off the paper, right? Doesn't fit. Now it's symmetrical, right? So I'll put a point here at 2, and I'll put up here a point at 8, and way up there somewhere, okay? So I just put it in. Okay, it's supposed to be round at the bottom. It's kind of hard to make it round without pointing on this one, but it's supposed to be curvy. Okay, now the parabola looks twice as tall, doesn't it? Skinnier, right? All right, what about B? What's going to happen with B? What's going to happen with B? What's going to happen with this graph? Yeah, it's going to be half as tall. Totally right. It's going to be half as tall. Does that make sense? So this one's going to be half as tall. So instead of 1, 1, we're going to go 1, 1 half. Instead of 2, 4, we'll go 2, 2. And instead of going 3, 9, we'll go 3 and 4 and a half. So the x values stay the same because we're going to plug in 1, we're going to plug in 2, plug in 3. But what happens is their heights change. They're half as tall, right? Okay, so real quick, if I plug in 0, I get 0, but half of 0 is still 0. That makes sense. Half of 0 is still 0, right? If I plug in 1, I'd normally go 1, 1, but this time I'm going to go half as tall. So 1, 1, I'll go 1 and just a half. If I plug in 2, 2 squared is 4, but I'm not going to go up to 1, 2, 3, 4. I'm going to go half as tall. So I go 1, 2. If I plug in 3, 1, 2, 3, 3 squared is 9, right? But I'm not going to go up to 9. I'm going to go half of 9, which is 4 and a half. 1, 2, 3, 4 and a half. Okay, now we could do the other side because it's symmetrical, right? So I'll go here, and I'll go here, and I'll go there, and I'll graph that in. How am I doing? Okay, the last one. There's a little bit of a hint what we're going to do is because the graph I put up there. I mean, you kind of know what it's going to be just by the way I did the graph. Megan, do you have a question?
Why are we only graphing 3 points? Or like 3?
Oh, we could do more. Real good. That's actually a very good question. We could do more, but a lot of them are going off the paper. So I could go 1, 2, 3, 4. What's 4 squared? 16. So it's really high, right? Does that make sense?
Yeah.
And I got the general shape. I could probably do this one because half of 16 is 8. So I could probably get this one. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I could get this one, right?
Does it matter how many numbers we
No, I think if you use all the way from -3 to 3, it's what I need is basically the shape, right? So you get the right shape and put it in the right place. Say it again. I want the right shape, right, in the right place. Does that make sense? Good question. Because we could graph more points, but then they start going off the page, right? Then we don't have room for them. Okay, f of negative x. So this one's going to be a reflection over the x-axis, okay? Go ahead and write that down. I'll show you why, okay? Go ahead and write that down. I'll show you why. Okay, it's a reflection over the x-axis. So I told you yesterday that y is the same thing as f of x, didn't I? So I said whenever you see f of x, just think y, right? I told you that yesterday. You see f of x, just think y. Well, if I have a negative f of x, then I would have to have a negative y, right? So if all my y values are negative, then whatever goes up is going to end up having to be negative and go down. That's why it's a reflection of the x-axis. Or vice versa. If it's going down and then make it negative, then it's a negative with a negative makes it go up positive, okay? So let's just do this one. So same thing. We're still going to go 0 squared is 0, right? 1 squared is 1, but it's going to be going down negative 1, right? 2 squared is 4, but instead of 4, we're going to go down 1, 2, 3, 4. 1, 2, 3. 3 squared is 9. We're going to be going down 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, Megan, awesome question. If I did 4, it'd be negative 16, but it's going to go off my page, right? Yeah. And of course, we know it's symmetrical, so I'll just do the other points on the other side of the y-axis. I got that, and I got that, and I got that. I'll just draw it in my graph. Okay, how's that? Okay, everybody thumbs up? Okay, not a whole lot of homework, 5 through 9 and 59.